Greetings, Spartan fans. 7-6 double angle formulas. You will need your identity sheet. Double angle formulas are going to be the ones that say the sine of 2 theta and the cosine of 2 theta. And notice that there are 3 versions of the cosine of 2 theta. So when we're doing identities, you can use any one of these 3. Okay. I consider most of this video to be a plug and chug, so you may not find it necessary to even watch. Here we go. So I'm going to look at something like, given that the cosecant of theta is negative root 5 and the cosine is less than 0. Okay, so the cosecant is the reciprocal of the sine. So I'm figuring out here, where is the cosecant negative, which means the sine is negative, and the cosine is less than 0, which means that it is negative. So where on the unit circle are both the sine and the cosine negative? And I believe that is quadrant 3. So much of this comes back to just drawing triangles and labeling sides. So the cosecant is hypotenuse over opposite. Hypotenuse is never negative. Hypotenuse is never negative. So let's figure out what the adjacent side is. And it needs to be negative. Be careful with those signs. Let's see here. I don't want to make any careless mistakes. So I'm just going to work it out here. Maybe it's, well, I don't know. We'll see. X squared equals, this is 5, 1. X is plus or minus 2. And in this case, it's negative 2. And it's negative 2 because it's in the third quadrant. I hope that's right. 4 plus 1, 5. Yeah. Okay. From here, I can ask you to evaluate anything. I can ask you to find the, evaluate the 6 trig functions, etc. I'm going to ask you to find the sine of 2 theta. The sine of 2 theta is very common, and you're actually going to use it quite a bit in calculus. It would be in your best interest to actually memorize this one. So this is going to be 2 sine cosine. Okay, so let's just plug in. So the sine of theta is negative 1 over root 5. I'm not going to rationalize it now. I will rationalize it later. And the cosine, actually, I will only rationalize it if necessary, which in this case, it will not be necessary. So let's go. This is going to be 4/5. That's it. And let's do the cosine of 2 theta. So you can use whichever one of the 3 formulas you want. You can use whichever one of the 3 formulas that you want. So you were given the cosecant, which means that you know the sine. So I'm going to use the formula that involves sine. And the formula that involves sine is 1 minus 2 sine squared. Doesn't matter which one you use any one you want. Now, being that I'm on my own, I better hope that I found the sign correctly. So this is 1 minus 2. Sine is negative 1 over root 5 squared. Sine squared means sine times sine, just the notation. So again, let's just evaluate. So this is going to be 1/5. And I believe the answer to this is 3/5. 1 minus 2/5 is 3/5. Okay, and that is your basic double angle formulas. So in this video, you're going to be just evaluating. Actually, let's do something that's a little bit more interesting. If you have your book, I'm going to look at page 497, and there are 2 pictures on page 497. So I'm just going to take a minute and draw those. So these are the two visuals, diagrams given in the book. Okay, so I don't know what A is, but I do, because if Y is 2, plug in. So if Y is 2, so that's going to be x squared plus 2 squared equals 5. So this is going to be 1. So this point on the circle, given that y is 2, I just plugged in to figure out that x was 1. Oh, be careful. It's in the second quadrant, it's -1. I'm going to do the same thing here. I know x is -1/4. So it's going to be -1/4 squared plus b squared equals 1. That's 1/16. 1 minus 1/16 is 15/16. So that is root 15 over 4. And it is in quadrant 3. So this point right here is -1/4 negative root 15 over 4. So now I know the coordinates of these 2 points. Okay, so I'm not sure why they did theta and alpha. I think you're more used to alpha and beta at this point, but we'll deal. Okay, I've got my 2 points, etc. And let's do, let's see, how about the tangent of two theta? Okay, well, when you evaluate the tangent of 2 theta, you'll notice that 2 theta is not on your identity sheet, but it sure is, because tangent is sine over cosine. So this is the sine of 2 theta. I hope I have enough room. Over the cosine of 2 theta, which is 2 sine cosine. Over the cosine of 2 theta. So again, remember that there are 3 different formulas that you can use for the cosine of 2 theta. So you can pick whichever one you want. So in the previous example, I used 1 minus 2 sine squared. So how about this one? We use 2 cosine squared minus 1. Okay, and let's go back for a second as I'm looking at this first circle that involves theta. So we're going to ignore alpha temporarily. You know that the radius of this circle is root 5. And that's going to become important when we are doing the evaluations of the sines and the cosines. So here we go. So 2, the sine of this angle is going to be 2 over root 5. The cosine of this angle is going to be -1 over root 5. And I'll be honest, if you get the sine and the cosine mixed up, you're actually okay, because when you multiply, order doesn't matter. All over. I get so nervous when I do these problems because I'm on my own and I think, oh my gosh, I hope I didn't make a mistake. I don't want to start all over. Okay, theta. So the cosine is -1 over root 5 squared minus 1. All right, so this is going to be -4/5 in the numerator. Over. This is going to be +2/5 minus 1, which I believe is -3/5. So the answer to this is 4/5. I wrote 4/3. It is, oh my goodness. I'm sorry. I had it right the first time and then I crossed it off and I got it wrong. How about +4/3? Which was right the first time? So for this particular example, we didn't need the alpha angle, but you might want to refer back to this video because you do need it for some of the homework problems. All right, let's take a look at an identity. So there are a couple of these in your homework as well. So I haven't done this one yet. Let's just give it a go and see what happens. Let's look at, how about, I want to do a double angle formula. The cotangent of 2 theta. So as soon as I write down cotangent, I'm thinking cosine over sine is equal to 1/2 the cotangent theta minus the tangent of theta. Let's start on the left. That's what we normally do. And if it doesn't work, then we'll start over and look at the right. Okay. So the cotangent of 2 theta is going to be the cosine of 2 theta over the sine of 2 theta. The fact that there are 2 different formulas for cosine 2 theta, that might be a little annoying actually in this case. So I know that the sine of 2 theta is going to be 2 sine cosine. Sometimes having having too many choices is not a good thing. I'm looking ahead and I want cotangent minus tangent. I'm going to go with cosine squared minus sine squared. The reason I chose this one is because I've got 2 different functions in the numerator and I have 2 different functions in the denominator. So this is going to be cosine plus sine, cosine minus sine. I'm not sure that I'm going to be able to get this to work. It's difference of 2 squares. I've got my 1/2. I've got my 1/2. Okay, and I'm thinking, this isn't going to help me. This isn't going to help me. So I'm going to actually, for the sake of the video, I'm not going to erase and start over. I'm going to separate this as cosine squared over 2 sine cosine. Minus sine squared over 2 sine cosine. I'm liking this better. Okay, so I can reduce this. This becomes cosine over 2 sine. There we go. And this becomes sine over 2 cosine. There we go. So this becomes cosine over sine, which I believe is cotangent. So this is cotangent over 2 minus tangent over 2, which is indeed 1/2 cotangent minus tangent. You would have gotten the same answer had you chosen one of the other 2 identities for cosine 2 theta. The reason I chose this one is because my answer has 2 different functions where I'm headed, and cosine and sine are 2 different functions. And there you have it, Spartan fans.